Bonjour à tous, je vais faire juste une petite intro en français. Donc c'est une session sur Micronaut. Donc je suis avec Graeme Rocher qui est le fondateur du framework, qui ne parle pas du tout français. Donc si ça convient à tout le monde, on va faire toute la session, les 3 heures en anglais. Si jamais vous avez des questions ou des choses que vous ne comprenez pas, n'hésitez pas à vous lever la main. Vous pouvez poser votre question en français, mais par contre je répondrai en anglais pour qu'ils puissent participer, si ça va à tout le monde. Ok? Ok, parfait. All right, so let's start with presenting ourselves.
Sure.
Okay.
So, yeah, welcome to the session on Cloud Native Apps with Micronaut 4 and GraalVM. A little bit about me. My name is Graeme Rocher. It is a French surname. I'm aware of that. My grandfather's name was Jean-Pierre. Unfortunately, he did not pass the language down the chain to me or future generations. So it's generally only a problem when I hand my credit card over in France and they speak to me in French. But I do speak, interestingly enough, Spanish and Basque. So if you want to speak any of those languages, a bit of Basque 50-50, but if you want to speak one, otherwise I'll hand the questions over to Cédric. So I've been working at Oracle since 2020. And prior to that, I created another framework called Grails before Micronaut. And you can connect with me on social, on those links, if you so choose. And I'll hand it over to Cédric.
So yeah, so my name is Cédric Champeau. So I also work for Oracle Labs on Micronaut. I've joined maybe 1 year after you.
Yeah.
So previously I was working for Grails, so all the demos I'm going to do today are going to use Grails, but if you're Maven fans, okay. It's, yeah. It's going to be a problem for me, but
yeah.
I can answer some questions.
Even I'm going to demo in Gradle, so...
Yeah. So the rest, it's just that my hobby is basically astrophotography, so if you're interested in that, just follow me on a specific master account. So I think that Graeme didn't mention he's on Twitter. I'm not. I left Twitter back a year ago, something like that. So the only way to ping me now is through Mastodon, if you have that.
Yeah. Actually, I should have updated that link to X or whatever it is now. To be honest, I don't hang out there that much anymore.
Yeah.
But yeah, I am still there around lurking. So let's talk about the agenda then. So we're gonna go quite deep into Micronaut 4 specifically, and what's new in the framework. But prior to that, do an introduction. So who in here has used Micronaut before, or no? Okay. Well, then we'll do some background intro.
That's good.
And why you would choose it, and some fundamentals, and talk about GraalVM. And where we are today. We'll talk about some of the nice features that have come in recent releases. In terms of core updates, Cédric will do a lot of talking about Micronaut Data and test resources and testing strategies and how those things have improved. And we'll talk about Loom and web and cloud and all those things, and hopefully give you a platform to go away and try out Micronaut and build cloud native apps with it. Okay. So a little bit of background of the frustration that led to the creation of Micronaut. So we, whenever you build a framework for Java, you typically use a set of building blocks to build a framework on top of it, right? On top of. So if you consider something like Spring, which I'm sure a lot of you are aware of, those building blocks were the use of Java Reflection, the Reflection API, runtime creation of proxies, etc. Those are the fundamental plumbing of the way the framework like Spring works. But the problem is that the JDK and the Java API kind of is quite limited in lots of ways. It'd be lovely if we could expand it, but it doesn't, for example, model certain things that a lot of concepts that frameworks are based on top of. For example, has anybody heard of an annotation stereotype or a meta annotation? So like if you have an annotation that has another annotation on it, right? That other annotation that's on the annotation is called a meta annotation, right? So that's quite a fundamental concept in Spring, because if you think of anything you want to make a bean, or you meta annotate it with @bean or @component, and then whenever you use that annotation, so you have to model that, right? And typically, there's nothing in the Java API that lets you look up stereotypes or compute what annotation is annotated with what. It's all, and throughout the Java framework tooling ecosystem, there have been replicated efforts to model this independently. So if you look at something like Jackson, Jackson has its own annotation model of the way annotations are working, because it's again based on reflection. The other problem was that generics were added later in Java. So if you base a framework on top of a reflection and you're doing runtime analysis of the framework, you typically of the user code, you typically have to use the reflection APIs to figure out what the actual type is. So if you've got a list of string, at runtime, you just get a list. There's no there's no string concept of what it's. So you have to kind of work it out from the signature, and it's very complicated to do so. Reflection is slow to initialize as well, and then there's also a lot of caches. So when not a lot of people know, but when you read a reflection from a class in Java, what happens is the JVM reads the reflection information for the entire class. So that means all fields, methods, constructors, everything, and stores this data in a cache. And the cache is held using soft references. So soft references are not garbage collected until the JVM is running low on memory, right? And what can happen is this metadata gets read. And for example, Spring will have its cache of metadata. So java.lang.reflect.method, java.lang.reflect.constructor, java.lang.reflect.class. And it will build up this cache of all this data for the reflection information that Spring needs. Then you'll use another tool in Java ecosystem. Let's call it Hibernate. Hibernate is also based on reflection. So it will build up its own cache of all that reflective information. And then you'll include Jackson. And Jackson will build up its own cache, and suddenly you have all these replicated caches of all this reflective data holding on to these java.lang.reflect.methods, different places, replicated across, and it's really wasteful, really wasteful. So, and then class path scanning, so there's nothing in the Java that lets you discover at runtime, tell me all the classes annotated with foo. There's nothing in there, right? The frameworks have to hand roll this. And then historically, there was a lot of complex dynamic class loading requirements in something like Tomcat, where they want to unload and reload classes, so these class loader hierarchies. So a lot of really difficult challenges. And so when we started looking at how we could improve performance, and reduce memory consumption, improve startup time, reduce the footprint of a Java application. We did a lot of profiling of Spring and Grails applications, and spent a lot of time profiling startup performance and memory footprint, and realized the only way to optimize this is just to not use reflection, right? Just avoid initializing reflective caches, avoid doing scanning, avoid creating runtime proxies, and just say no to all of that, and instead take a different approach, right? And that different approach is what Micronaut took. So, and this is not like new. Micronaut is not like the one that's pioneering this approach, really. I think if you look at historically, when nowadays a lot of Android applications are written in Kotlin, but if you looked at historically with Java, there was a lot of a strong desire to avoid reflection in the Android ecosystem. Because why? Because it's wasteful, it's memory intensive, it's slow. So like an Android app on your phone won't use any reflection whatsoever, because they have similar requirements we were trying to hit, which was like, you want your Android app to start fast, you want your Android app to use a little bit of, not use a lot of memory, and how did they achieve that on Android? They achieved it with a whole ecosystem of annotation processes. So things like Dagger, which they use for dependency injection, and so forth in Android. But that was on the client side. Like, so we were thinking, like, why is this only happening on the client side? On the server side, you know, shouldn't we be equally as concerned about how much memory our applications are using in our server-side deployments? You know? I mean, historically, people have been like, oh, well, memory is cheap, just throw more memory at it, right? And then you see deployments where they're allocating 2 gigabyte of memory to a Spring app because that's how much it needs to run, right? And that's what we wanted to avoid, particularly in containerized deployments, in serverless, but at the same time, we wanted to build something that was fast, efficient, small, but also didn't sacrifice like developer productivity. When we started building Micronaut, there were a lot of frameworks that were fast, efficient, things like Vertex, but they didn't have the same developer productivity as, or a developer productivity focus, like something like Spring. So we wanted to create something with a strong focus on developer productivity, and Micronaut was born. And you know, when Micronaut was created, it definitely sent ripples through the whole Java ecosystem, changed a lot of things. Our competitors, new competitors came along, like Quarkus. Spring, you know, has changed a lot, tried to evolve. So it was definitely like, we're on the right path with what we've built here, right? Because we're making meaningful change across the ecosystem. So Micronaut has like solutions to all those problems I talked about. For the annotation API, what we do is we hook into Java-C, into the Java compiler, and we pre-compute all the annotation information that we want to compute whilst the application is compiling. So, for example, we compute what annotation is annotated with what, where annotations are used. And that means we can create indexes. So imagine you're implementing a framework, right? You're a framework developer, put yourself in the head of a framework developer. And I want to implement a framework like Spring. You need to find all the classes that are annotated with the controller, and all the methods of the controller that are annotated with get mapping, at put mapping, at all these like HTTP mappings, and you need to do that at startup time because you need to calculate all the routes, all the paths that the HTTP server maps to in those annotated classes, right? So with Micronaut, we compute those indexes whilst the application is compiling, instead of waiting until runtime and doing a runtime analysis of all the classes and trying to figure out where all the routes are and loading all the classes and traversing the class path and using ASM and bytecode analysis and etc. techniques that have historically been used. We also came up with a solution for type erasure because we are processing source code And the beauty of source code is that you can see when something is a list of string. You know, it says there in your code, list, square, angle brackets, string. So we can just store that information and have it ready for the framework at runtime, so that the framework doesn't have to get this field, get the at runtime, reverse compute from the field the actual type argument to the list, etc., all using reflection. And we aimed for 0 reflective caches, and we hit that goal probably in Micronaut 3, because and probably we truly hit that goal in Micronaut 4, because in Micronaut 4 we defaulted to Micronaut serialization, which replaced Jackson, and now you can build a complete application. We're using Micronaut Data for reading and writing to the database, Micronaut serialization for serializing and deserializing JSON, and not have a single reflective data cache in the entire application. Obviously, if you pull in something like Hibernate, you're on your own. But you can essentially eliminate all these caches of reflective information. We eliminated class path scanning, because as we go compiling, we can compute the indexes to all the things that we're interested in. And there's no class loaders. Well, obviously there is a class loader, because there's always a class loader in Java, but it's just a system class loader. So there's no dynamic class loading in Micronaut, and that makes the debugging a lot easier. You'll never hit an issue in Micronaut where you're like, why is I know my class is there, but why is it not loading? It's loaded in a different class loader. Oh no, like why? That's driving people mad. I used to go mad with that in Tomcat, and then why do I need to use the thread context loader here or this class loader there? And those issues just go away. So we believe the future is these intelligent compilers and smaller, leaner runtimes. So a net result of moving all of this logic into the compilation phase is we've able to make the runtime a lot smaller. So, for example, a Micronaut app with JSON serialization, HTTP server, everything in it, is like 11 megabyte jar file, right? The equivalent, Spring or whatever traditional app is like 30 megabytes of bytecode, right? Collapsing the amount of bytecode, making the whole runtime smaller. And you can see it when you compare things the way Micronaut works. So for example, Jackson data bind for JSON is 2.4 megabyte jar file. Micronaut serialization is 400 kilobytes, right? So because everything happens in the compiler, it leaves the runtime lighter, smaller. And I think that feature is playing out with more intelligent compilers. There's lots of different frameworks now, other than Micronaut. One of them is Graal, which we'll talk about in a moment, which are focusing on moving more processing into the compilation phase to make our runtimes more efficient. Which brings us to Graal. So GraalVM, I hope most of you have heard of GraalVM, probably many people. So GraalVM is on the one hand, it's a distribution of the JDK. So you can use it like any other version of Java. And when it's in terms of when it's distributed as a JDK, it replaces the JIT compiler. And by replacing the JIT compiler, you can improve the throughput of your normal Java application by between 10 and 15%, depending on what you're doing. Reducing throughput, latency, reducing memory use. But it's probably more famous for native image. So native image is a tool that lets you take your Java application and turn it into a native executable. And that has many, many positives. It has some negatives too, which we can talk about. We can talk about as well. But it has many positives in terms of runtime footprint and memory consumption, startup, etc., etc. And Micronaut and GraalVM, they work really well together, and that is the case because of what I spoke about before. So, because Micronaut doesn't do any reflection, doesn't do any dynamic class loading, doesn't do anything dynamic at all at runtime, that means it's very easy for Graal to perform what's called a closed-world static analysis, where it statically analyzes your app to figure out how it works. When you introduce dynamic behavior for Graal, in Graal, introduce dynamic behavior in your Java app, you have to tell GraalVM about it, and that's done in the form of configuration files. So say I'm using Jackson and I'm serializing and deserializing an object to and from JSON. Jackson is reflection-based, so that's completely dynamic, right? So it needs to know what methods you're reflecting on, what classes, what fields. It needs to know about that. You have to tell it ahead of time. And that's getting easier. In fact, in the newest version that just came out, there's a way to say, add reflection data automatically for all classes in a package, and it will just import everything, right? But it's not enabled by default because the goal of the Graal team is, and native image, is to create as small image as possible. And if you pull in all the reflection data, then you create really big images, right? But in terms of Graal, Micronaut is really simple because there's no configuration at all needed to work with GraalVM native image. And this is very different to the way other frameworks have integrated with Graal. So there's basically two ways you can integrate with Graal. You can not do anything that requires you to configure Graal, i.e. don't do reflection, don't do runtime, dynamic class loading, don't do anything. Just create a fully static application. Or you can generate or create the reflection information necessary for the application to run. And a lot of frameworks have chosen the latter path, so they're carrying on doing reflection, etc., but just like configuring Graal, right? Micronaut does the former path, which is, we think is better because it's easier to rationalize about, because your application is always the same, whether in JIT or native. There's no difference, it's the same app. There's no extra configuration or differences. Once you've converted your application into a native image, startup time is ridiculous. For a small app, it drops from, Micronaut startup time is already fast. On this machine, it's about 300 milliseconds on JIT for a simple app. But on native, it's like 10 milliseconds, right? And memory consumption drops significantly. In addition to that, we have, at Oracle, worked on a set of curated modules for Micronaut and Graal that we continuously test and build, that we know allow you to build cloud portable applications. So I recommend you check it out at graal.cloud. What we want is to make it possible for folks to build cloud portable applications that can be deployed to AWS, Azure, GCP, and Oracle Cloud. And we want to verify that all of those integrations with those different clouds work with native image. And the application can be portably moved from different clouds, from one to another, right? And it always works. So we're doing a significant amount of effort in creating like an opinionated project generator, tutorials, guides, to propagate the use of Graal across all the different clouds, right? And that's the aim of the Graal Cloud Native Initiative. Anyway, that's probably enough talking. I'll do a quick introduction demo of Micronaut to show you how you get started.
Just before you do that,
yes,
I don't think you mentioned that Micronaut is actually open source.
Yes, should I have said that? I absolutely should have said that. Micronaut is Apache licensed, Apache 2 licensed, open source, the entire framework, right? So fork it to your heart's content, contribute back. We love contributions. So yeah, so there's actually nowadays a variety of ways to get started with using Micronaut. So one way is to go to start.micronaut.io, and this is a project generator where you can create a Micronaut application. You can choose here your version of Java, and obviously we're defaulting to 21 nowadays because it's the latest and greatest. Your Micronaut version, the language. So we actually support 3 languages, and that was an interesting challenge. I think Micronaut is probably the only framework that or the only tool that I know of in the Java ecosystem that has been able to support Java, Groovy, and Kotlin simultaneously through plugging into their respective compilers, right? So we actually have a compiler API that the whole ecosystem is built around that works with all these different languages. And actually for Kotlin, we have 2 variations because recently we added support for KSP, which is a new compiler API. So we support 3 different languages. We support 3 different build tools. I mean, one thing to point out is that Micronaut doesn't actually need a build tool to work. It's just a Java annotation processor. So I even know folks that I've got working with Bazel and other things. But we have really great plugins, largely thanks to this man over here, particularly Gradle. And the plugins just make your life better, right? So we don't have plugins for Bazel. Sorry, I don't know much about Bazel. But it's perfectly possible if you want to configure everything yourself to do so. We also support different test frameworks, JUnit, Spock, CodeTest. And in this UI, you can add search for different features that you want to support. So if you want to add OpenAPI support, for example, or JDBC, with different integrations, or you're interested in JMS, or Kafka, you basically can search for an integration that you want to add and add it to the project in order to get going. If I were to add, I don't know, for example, I want to add validation support. So here's another example of how Micronaut eliminates another reflective data cache. So if you use Hibernate Validator, Hibernate Validator is based on reflection, so it'll create another cache, yet another one. If you choose Micronaut's Validator, it's all based on compilation time data. So I can choose the validator. And once you're done, you can click Generate Your Project. You can preview it if you want to see what it's going to be generated, and look basically what's going to be generated. And you click Generate. You can download the zip file, or you can copy the commands to use curl from your terminal to create the app. But having said that, a lot of modern tooling, and I probably should have opened IntelliJ, which I'll just do that quickly. For example, in IntelliJ, you can go New Project, and here you can choose from the left Micronaut, it basically provides integration. You could even host your own version of Micronaut Launch if you had an internal version, and you could fork it and create your own version and change its URL and point it internally if you wanted to. But you can use the project wizard in here, and also in VS Code. There is a Micronaut project wizard where you can say Micronaut, create Micronaut project, and then go through the steps to create a Micronaut project. So we can create a Micronaut application. We can choose our version of Java. We can say I'm going to create a demo. I'm going to use Java. Oops, go back. I want to choose validation. Click OK. Use Gradle, obviously. Clear choice. No?
Best choice.
JUnit as my testing tool. And then we can go to demos and just create it in here for the moment. and that'll create my application in VS Code. No, I don't want to do that. Yes. Okay. Okay. Reload. There we go. Okay, so I'm using VS Code because I'm like living on the edge. We'll switch between demoing in VS Code and demoing in IntelliJ. But basically, yeah, I have created an app here. And as you can see, in terms of what it looks like any standard Java app. You've got a source main Java. Here we have a application class, which is the main entry point for your app. So when you run the app, you can run it from here. And as you can see, Micronaut Startup, even in JIT, is pretty good. And I can't tell you what a profound impact that has on the testing experience, because a lot of frameworks, other frameworks, they have very complex testing frameworks because they want you to mock out things or only start up a part of your application, a slice of your application, because if you start the whole thing, then performance is horrible in your test. So you have to use mock MVC or mock something, to write tests. And Micronaut has a very simple test framework because our philosophy is you should write as many functional tests as you possibly can, because in my opinion, the more functional tests, there's a debate to be had about unit test versus functional testing, but for me, if you have more functional tests, you have higher quality tests. A lot of low-level unit tests, for me personally, make the code harder to evolve and force you to make changes to your production code in order to support testing it. So a lot of people have to falsely add protected methods so that you can extend them and replace them and mock them and whatever, and in order to craft this perfect unit test. So obviously that's something that can be debated. My personal opinion is the more functional tests you have, the better, because functional tests you're testing the real application in its real scenario. So the way you write a functional test in Micronaut is you can, in JUnit 5 or in Spock or whatever you want, is you add at Micronaut test to the test. And what that does is when the test is started, it will start Micronaut, right? So it'll start the whole of Micronaut, including its HTTP server and everything. But in addition, it lets you inject any component, dependency inject any component into your application. And you can do that in a number of ways. One way you can do here is I'm using jakarta.inject. You can also, if you don't like jakarta.inject, you can also inject just like method parameters of your test method. That'll work as well. And you can then run the test, and it passes. And look how fast that is. That's as fast as a unit test, and it started the full HTTP server, right? And it's instantaneous, and that means you can write thousands of functional tests, loads of thousands, if you look at Micronaut Core's test suite, we have 4,000 functional tests, and the whole thing runs in 15 minutes or something. So 10, even, yeah, we have thousands of them, right? So yeah, Micronaut Test is the testing framework. And in terms of configuration, you have a application.properties file, much like Spring or micro-profile applications, where you can specify configuration. All modern IDEs like VS Code and IntelliJ will let you autocomplete the available properties, right? And IntelliJ is a little bit better in that it gives you an error if you put something invalid. But you can autocomplete the available properties, and you can navigate to where that configuration is defined from your IDE, whether that's in IntelliJ or VS Code. And in terms of what the build looks like, this like I said, this is using Gradle. But if we were using Maven, we also have Maven plugins. Our Gradle plugins are super awesome. You just define a plugin here, and then it simplifies the whole build greatly. There's some interesting configuration here where you can define like whether you're using JUnit or Spock or as your test runtime. We allow switching the runtime of the server, so the default is Netty, but we also support Jetty and other things. And there's some configuration, different configuration you have for creating Docker images, which Cédric will explain more. So that's, I think that's more or less like I have to go back here. Demo of how to get started. So project setup. Like I said, you can go to Micronaut launch and start that way, or if you have an IDE, IntelliJ, Ultimate, or VS Code, they have wizards. We also have a command line tool called MN that you can install via SDKman if you want to create via the applications via the command line, not using curl in a bit more of a user-friendly way. It's not a required component. If you don't want to install it, don't install it, but if it's there if you need it. The testing framework is Micronaut Test. In this case, I demonstrated JUnit 5. It spins up the whole server and lets you inject components of your application into, and we'll talk more about dependency injection in a minute. So in terms of what we've evolved in the newest version of Micronaut, which came out not so long ago, we added a baseline minimum version of JDK 17. But we also updated and got it ready for JDK 21. And in fact, now that JDK 22 is out, it's ready for that as well. We improved GraalVM hugely. So in Micronaut 3, we had a lot of like GraalVM metadata embedded in different Micronaut modules for things that did require reflection. And we contributed those to a shared metadata repository that is shared with the Spring team and the Micronaut team, and we simplified, moved to runtime initialization, and now it's a lot simpler. We improved performance and memory a great deal, so throughput is like 50% better. Micronaut is one of the fastest frameworks that you can possibly use today. We got a requirement internally at Oracle was like to try and get Micronaut's performance to as close as possible to raw Netty as we can, humanly can, and we're very, very close to raw Netty performance, right, in terms of throughput. So there's after lots and lots of work and benchmarking and iterating and optimizing, we had a very small overhead on top of Netty. The framework's more modular. We added an expression language, which we'll demo later. Virtual thread support, context propagation, improved context propagation API, and a lot more. And then we upgraded everything, minimum versions in terms of things like Gradle, Groovy, Kafka, various SDKs. And with that, I think it's going to time to move on to a GraalVM demo. Yep. Which I'm going to hand over to Cédric, who will take over and keep demoing.
Oh, that's not the right window. Okay.
Yeah, so in Micronaut 3, we had a lot of issues with, for example, when you want to propagate your like MDC from one microservice to another, or MDC data, for example, or you want to, for example, for reactive transaction management in Micronaut Data, you also have to propagate the reactive transaction across different reactive contexts, because we support reactive, but we also support non-reactive. So we had a lot of complex requirements to support, like context propagation for normal threaded, single thread. Well, not single thread, but like normal thread per kind of request use cases, but also for reactive, using Reactor, using RxJava, etc. And to get it all working, it required like completely rewriting the way context propagation worked, such that developers don't, as little as possible, got into a situation where, suddenly my request ID disappeared and I expected it to be propagated, or my reactive transaction wasn't propagated, or whatever it may be. So we built a generic API for propagating context, and we also integrated with the Micronaut observability, context propagation stuff, and also rewrote a lot of the internals to use Reactor, because it's like using a Reactor. It's got support for context propagation. So the story around context propagation is a lot better now.
Yep. Another question?
The easy way to know the dependencies
is using reflection at runtime.
Yeah, an easy way. Well, we do our current implementation. If dependency injection requires reflection, and I think there's only one case where it does, which is a private. Well, there's two cases. There's two cases where reflection is required: a private field. So if you do add inject on a private field, or if you do add inject, if you have a superclass that has add inject on a package provided field and you extend it in a different package, then it requires reflection because there's a different package. Right? But in both those cases, Micronaut falls back to using reflection and generates the GraalVM metadata. However, we do recommend that you do not, in fact, I personally recommend that you do not ever use field injection. It's much better constructor injection. One, because you don't need inject as a keyword. You just add a constructor parameter. And two, because constructor injection never requires reflection. Because it's not possible. It's compilation error, I think, if you try and have a private constructor. So it won't let you do it. But there isn't a way today to say, but it might be useful, I guess, to print a warning.
I think the question was more like use a transitive dependency, like, I don't know, you use Hibernate, and it uses reflection. How do you figure out that it uses?
I mean, one way you could do it is to run the GraalVM tracing agent. If you run your tests with the tracing agent on, it'll generate the reflection metadata. And if you can see a lot of reflection metadata being generated, you can see. So if you do, maybe you can demonstrate that Test -p agent, and it generates the reflect config file. And you can see which part of your application is generating reflection. And that's probably a useful use case of the tracing agent.
Yes. Another question? If I go. All right. So I'm going to talk a bit more about the tooling and why it is interesting to use either the Gradle plugin or Maven plugin. The two feature sets are identical mostly. And show that using an application which is fairly simple, like have a web page where you can upload files to a server, right? And we're going to do that with Micronaut and native image with GraalVM, and maybe even pushing that as a Docker container, whatever, right? So I have prepared a small project where we have the basic Gradle file. So as Graeme mentioned, so the base here is that you have this Micronaut application plugin. So what it does is configuring the project, the current project, as a Micronaut application. So something we did not mention is that you can actually do multiple kind of applications with Micronaut, like not only Netty application, you can do CLI application, etc., etc. So the configuration is going to be a bit different in those cases. Or even if you target a function, you would have a separate configuration block. So this is provided by the plugin. So the plugins are going to give you some insights about what you can configure for a particular kind of module. And another one that you have, for example, is a library plugin. So this is in case you have a multi-module project and you have one module, which is the application, so it has a main entry point, but the other ones are just libraries that you use into that project, but you still want to use dependency injection and whatnot from Micronaut in that. So in this case, you would have a library plugin. So here it's an application, so we configure that, and we have some dependencies. So I wanted to show you one of the advantages of using this micro project with Gradle. So if you look at the project that I have generated here compared to what Graeme has shown, is that I have added one plugin here, which is called the platform catalog plugin. So when you do that, one thing that you can do actually in the dependencies here is to start using different notation, which is the type-safe notation of Gradle for dependencies. So there's what we call a catalog, which is called MN for Micronaut, and then you have dependencies available there directly. So instead of having this stringly typed notation for an external dependency, actually what we have is everything that is blessed by Micronaut. So everything that you find in a Micronaut platform is basically what you would have in a BOM, except that it is named and type safe. So here, instead of using this Micronaut HTTP validation thing, I can just do Micronaut, and then I have completion, like Micronaut, HTTP, and then validation, right? So I don't have to forget I don't have to remember about all the dependency notations. Everything is provided by the catalog. So I can replace this one. I can do, for the second one, annotation processor. So we have Micronaut third, so it's going to be in the Micronaut third, and then it's the processor that I need, etc., right? So I won't do that for everything, just add some shortcut, catalog, and there you go. So it simplifies a bit the dependency notation, and then basically it means that you don't have to handle all the transitive dependency version changes or whatnot. Everything is handled by the platform, the Micronaut platform that we provide. So if you look for support for, I don't know, Kafka, you will have that in that catalog, so you don't have to figure out the coordinates, Kafka coordinates. So that's just for the build for now. We'll talk about this AOT plugin a bit later. But now let's go for file upload demo. So for file upload demo, we have two parts. We have a server part and we have the client part. And it's going to be, this application is a monolith in the sense that the server is going to serve both the backend and the front end. So I don't speak JavaScript, unfortunately. So what I've done is that I have asked ChatGPT to generate me some HTML page and the JavaScript to do the upload. And it was mostly okay. Like, I only changed a couple lines. And basically what it told me is that in order to upload a file, you're going to have to use so the script, and in the script there's /upload post, right? So my goal is basically to implement that. So if we go into our source main Java, the application entry point is exactly the same as before. We don't have to change it. The only thing I'm going to add is this controller, and I'm going to remove that. I don't know why it's there. So the base is to create a controller with /upload and to fill that, right? So if I just start the application right now, we see that Grails is starting the daemon, and it's going to compile the application, and we're going to be able to connect to the application and see the interface. So this is what the page looks like, and if I try to upload some files there, so I'm doing some astronomy, so I have fairly large files that I can use for demo. So let's look at this one, Uber. So you can see that I have files which are gigabytes, right? So this is the files that I'm going to use. If I drag and drop, what we're going to see is that, right? So how do we get there? It's actually fairly simple. So something that you can do and that I recommend to do is that here, when I do Gradle run, The application is started in a special mode, which is the continuous mode. So it allows me to actually make some changes to the code and have instant changes visible in the application. So to do that, there's a little trick. So I don't know how I can make this sidebar appear. I don't know the shortcut. If you have it, give it to me, but I don't remember the one. So here you have all the Gradle tasks available, and there's one which is run. So if you do, if you create, say, a configuration, so let's start with removing all these ones so that I can show you the whole process. Remove everything, so I don't have anything. I can right-click on that, click on run. But if I do that, the application is started in just the regular mode. So it's going to start the application, run it, but it's not going to listen to the changes. So if I make any change to my code, it's not going to work. So now my controller is empty. If I go back and try to upload anything, whoop, why is it working? That's weird. It's not supposed to happen. Interesting. Or maybe it's just a UI thing. I don't know. Yeah, file not found. Okay, so it's just JavaScript. So ChatGPT didn't get it right. Anyway. So we have to complete that controller, but if I do that and I change something there, nothing is happening. Like I saved my file, nothing is happening. Now I'm going to change that configuration, so it's that the trick that I suggest that you do if you use IntelliJ and Gradle, you just go there and add -t in the beginning of the run. And now that if I do something like that, start the application again, now it's listening to these changes. So I can go and add, I don't know, a property, private final string foo. Hello.
And make the font bigger.
If I save the file, yeah, but if I make the font bigger, then we wouldn't see that it's actually refreshing there. So, no. The content is actually not important. What is important is that any change that I make is going to be live changed. So if I duplicate that, say foobar, save the file, you see that the application is compiled and restarting in just a second. So it's really fast feedback, right? So you can make changes live. So I know that you're mostly fond of test-driven development. Sometimes I like to do the opposite, which is code first, the application, try first, and then when I'm fairly okay, I write the test, which makes sure that nothing is buggy. So let's do what I said. So upload controller. And this is not ChatGPT generating that. This is exactly what I've written before. So now I can make it larger. So to do that, the first concept that you introduced was dependency injection. So one thing that we can do is that we can actually inject a value which comes from configuration. So in this case, what this means is that I expect configuration property called upload directory. And if it is not set, then it would default to that directory, right? So if I go to my resource application.properties file, actually it's not defined. That property doesn't exist. So it means that my application is going to use and upload everything into /temp/upload. Okay? That's the goal. Of course, you should not upload to a temp directory. That's a demo. And then the rest is just about dealing with this multi-part form data. So I'm just creating a method which is annotated with @post, telling the content type and explaining that it's going to generate just explain, which is basically saying either the file was uploaded successfully or not. And then this API called streaming file upload is using some reactive APIs. So if you want to do that, there's these dependencies that you need to add, which is here Rx Java 3, right? So once you've done that, the rest is basically just copying a file, so nothing really fancy. It's just in a few lines, and my application should be rebuilt now because I've switched. No, it didn't change the focus. So now that it started again, I can go and take some files, drag and drop into the UI. So let's refresh, drag and drop, and let's go to /temp uploads, and there we go, the files are here, right? So this is a really simple application, just showing how you can have an UI. But one thing that I didn't explain is how these files, these static files, are served. So that's the last bit that we're missing. And they actually live into that public directory, but it's not default. It's not something that you would have by default. So you have to configure that. And to do that, the only thing that you have to do is in your configuration file, add some static resources, and basically it tells me this is going to be served from that class path entry public, and then you have resource mapping, and you can do whatever you want. If you have Micronaut security applied, you can add security rules, say that you want to prevent some users from accessing some static resources. It is also possible, etc., etc. So it is really a simple way to have a server serving some files. And the rest here is just, I don't think, we don't need calls here because everything is served from the same server, so that's fine. But this one was for my test because if the files were too small, then the demo was not great. And I think the default is quite small for the max request size. So just increase to 4 gigabytes and works perfectly fine. All right. I said we should have some tests. So how do we test something like that? Come on. No, you don't want to. Okay, let's do that. So how do you test that? So again, the test is annotated with @Micronaut Test. So I'm going to be able to inject everything I need into the test. And the way I've done that is typically here, I'm using this parameter injection that Graeme was talking about earlier. So we have this file upload client. So I have never written such a file upload client, so where does it live? It's actually in the test here. So what I have here is declarative HTTP client, which actually is going to connect to my server, and I have that only in the test. Like, this is the only place where I need it. So I can just inline this declarative client into the test. And what it does is basically saying, I'm going to connect to this /upload thing. And there's a single method, which is going to do this post and use a multi-part body file. And that's it, right? And that's all you need to implement a fully fledged client with Micronaut. That's pretty nice, I think. And one of the things that I like most, actually, about the project. Because once I have this declarative client, the only thing I need to do is basically check the logic. So I create a temporary file, write the content, and then calling this multi-part body builder, where I'm just adding a file to it, and I expect that in the end, it's going to pass. So let's run the test, because you should not trust me. And let's move that a little up. There you go. It passed. But if I say just that, just to make sure that the test fails, never trust a test that you didn't see fail, then everything is okay. So what we have done so far is implementing a server, which is this fat server, where you have all the client pages served from the server, and then you have this controller. Then we wrote a test to make that happen, and now we want to manage deployment. So how we do that? So I'm going to switch back to the command line to demonstrate the rest. Terminal, or maybe I'm going to use that with bigger font. So let's go to deep dive. And it's in demos file upload, so that it's easier for you to see that. So what I've done, I think the server is still alive, so let's stop it. So what I've done from the IDE is basically that, Grail-t run. So if I do that, Grail-w, sorry. So if I do that, it's going to start the application and it runs in JVM mode. There you go. Okay, runs, right. So notice the startup time there. So now what I'm going to do is Gradle native run. So this will take like a minute or so, and what it is doing is actually now compiling my application as a native binary. So all the code that I have for production, and only production in this case, is going to be compiled as a native binary using GraalVM. And what it means is that the deployment artifact that we're going to have is specific to my architecture right now. So I'm using Linux, you was using a Mac, so it means that if Graeme did the same on his machine, the binaries would be different. His would be compatible with Mac, mine is going to be compatible with Linux, right? So you have to be on the specific architecture that you want to target. So said that, the binary, you can take it, move it to whatever production environment you want. As long as it matches, it's going to work. The reason why it takes so much time is because we're not doing like what the JVM is typically doing. In order to generate a native binary, you have to figure out all the different paths that the code can take in your application. So you start with an entry point, and then the analyzer is going to say, okay, from that point, I can reach this part of the code, etc., etc. So it's going to create a tree of calls, and then once it has the complete world, it's going to generate and compile all the native code that is required in your application, and it will not contain all the dead path that you can have in all the, typically in a transitive dependency, you may use, I don't know, 10% of that dependency. And you have that in the jar file. And if you deploy that on production, you would have that. In a native binary, that code would not be shipped at all, because it would never be reachable. So that's why it takes a bit of time to do. So it means that this is typically not something that you would do on a developer machine, but typically generating a native image on CI is something that it makes much more sense. Yeah. No, so we don't need that because we actually added, and that's part of the metadata repository that Graeme was mentioning. So there's this effort which is to share some metadata between the different frameworks about transitive dependencies. So the Spring team is using the same. So typically the build tools figure out that you're using logback. So they reach to this metadata repository, fetch the metadata for logback, and it's included, so you don't have to think about that. Yes. Yeah.
So Micronaut itself avoids any kind of configuration for GraalVM inside the framework. You don't need to configure anything. But for third-party libraries like logback, some configuration is needed, and that configuration is housed in the shared metadata repository. If you want to know what configuration is applied, you can add, I think it's -- verbose to your native image flags in verbose mode, and it will print a list of configuration and where they're pulled from. Because basically what the metadata repository plugins do is they add some additional flags to the native image tool for different configuration files that get fed to it. So enable verbose mode if you want to see the exact configuration that was fed to the tool.
You can see already that this output tells you a bit
more gives you a bit of a hint,
everything that is included into the image. But it won't tell you about reflection. If you want reflection, you have to add some logging flags.
Yeah. So actually, that's an interesting. Once you get to the AOT stuff, you can see that Java.xml is taking 3.38 megabyte.
Almost 8. Yeah.
Yeah. So that's something that can be
improved. Yes.
Improved. We'll talk about that later.
But you've seen, startup time is 9 milliseconds. I can start again and see how it goes. So Gradle, 6 milliseconds. Yeah, that's
Pretty insane startup time.
so if you compare that to the almost 400 milliseconds just for the Java application. So let's check that it still works, because otherwise I would be lying. So there's nothing in my uploads directory. Let's try that again. I should do that. Yeah, it's happening. And let's look at the memory usage. Save file, upload. Yeah, there you go, like 140.
Yeah, it was probably because it would have used all the
Because of
netty
buffering.
chunks,
Yeah.
but you can feed in, typically in a production environment, you can feed in XMX setting, the same as with Java. So there's like the maximum memory allocated and the minimum. And with native image, you can pass in an XMX, and it's to be recommended in production to pass that limits the max memory. And you can get it to run in very, very small amounts of memory compared to Java without having memory pressure.
All right, so now then the next step is actually to do something called native test. And when you do that, what it's going to do is almost exactly the same, except that instead of generating a native binary for the application, it's going to do that for the whole application plus the test. So it means that you can run your whole test suite as a native binary. So you might wonder why you would like to do that. It's a good question. One reason is that despite everything that we've said, that it's a great world and everything works, yeah, in practice you can still have differences in behavior between native and JVM, because you may have some static initializers, you may have some classes which do weird things, or you could have missing reflection data. Like if a transitive dependency is using this reflection API on some class, and that you didn't run the agent to generate that, then it's going to fail at runtime for the native binary. So one way to figure that out is actually to run your test suite as a native binary itself, because in this case, the test suite itself would fail instead of having to wait until you're in runtime, right? So it's going to take a little more time because there are more classes.
One thing that's important to point out is that Micronaut is a suite of different modules, like Micronaut Data, Micronaut Serialization, Micronaut Integration of Micrometer, Kafka, etc. It's actually a multi-project ecosystem under GitHub, and all of our modules, we have native tests that use this native image testing, and so all of our test suites run natively. So we have a very high level of confidence that whatever you use in the ecosystem will work out of the box.
Yeah. So if you do that, the only difference is the output, basically, which is quite different from what you used to if you run it in the IDD, because there the only thing that you have is basically that report. And I'm mentioning that because I had a question before in a different talk, but the notion of container here has nothing to do with Docker whatsoever, right? This is not a Docker container. This is just terminology that JUnit is using about something which contains a test. So a container is typically a test class. So it means, yeah, two test classes. Actually, there's one because there's the test class, and then there's the test itself, which is counted as a container. So yeah, and if we look at this file, which is native test compile, we have that like 80 megabytes, and we can rerun that if we want to. Yeah, it's fairly fast. I don't know why it's not going to execute. Yeah, if I do that, it's better with because that's always confusing me with Z shell. Like it's CD'd. And, I don't want that.
No, you're in some weird directory.
Yeah. Anyway, so that's so we've demonstrated building from Java, building from native, but now what if you want to deploy that on a server? So typically you would do that with a Docker container. So we could do Docker build native. And what is going to happen is fairly interesting. So instead of building on my machine, basically what is going to happen is that it's going to build everything there and then create this Docker image which contains the application. So it's a multi-step Docker container build. Like the first step is actually using this native image inside the Docker container to generate the native binary, but then it drops that and only keeps the actual application generated, right? So while it's building, we can take a look at the generated Docker file if you're interested in looking at what it looks like. So it should be in build, native, no, it's Docker actually, Docker native. And then we have this native Docker file. So it fetches this native image community image and calls everything that you would have to do manually if you were doing that from command line. And you see all these xconfig things, right? So this is typically using this metadata repository that we were talking about. So we have metadata for Netty, we have metadata for, there should be logback somewhere. If you have good eyes, you should see that, but yeah. And then in the end, the only thing that we're doing is copying this application, right? So it should be almost done. No, it's done automatically. So the exclude thing is done automatically, and that's because as soon as you say, I'm using this metadata repository, you don't want to use whatever is bundled into the jar. So that's actually a good thing to mention. So you could have some of these libraries, like say logback, shipping inside the jar metadata, which is outdated. So instead, when you use the metadata repository, it's going to use our metadata. So it's, yeah.
I don't think I can know that it's there unless I look inside the library, right? So
yeah, yeah.
check and see if there is.
Exactly, yeah.
Unfortunately, it's the case that as GraalVM has evolved, some libraries in the community that did not update their metadata, either because they didn't have tests for all the different versions of GraalVM. So the metadata repository is a good solution to that because it's part of the GraalVM gates in terms of like releases, so that it has to pass, which means the metadata is much more up to date and kept up to date and tested. Because any metadata that gets committed to the shared metadata repository has to be committed with tests.
Yep.
So there's tests and metadata, and that's the important thing, right? The testing.
Yeah. But the thing of using the build tools is precisely that you don't have to figure out everything. Like. So it depends on how much committed you are on maintaining this metadata. So if you're the maintainer of a library, which is popular, and that users come every week and tell you, please support GraalVM, and that you're aware of GraalVM and you know how to do it, maybe it's a good idea to have that metadata directly into your project. However, maybe you're not committed onto maintaining support with GraalVM. In this case, you would say, okay, you guys are interested in using GraalVM, maintain metadata, and then it's going to be done in that repository, which is also open source, and then you can contribute. Oh yeah, yeah. There's a mic.
We forgot about the mic.
It's just a reminder. There's a mic, so if you have a question, you can come in front and sing us a song.
Yeah.
So what I've just done is just running this Docker container, and then you're basically done. So everything that you see there is handled by this application plugin that we mentioned in the beginning. So it does everything that we've showed for free. Like you don't have to configure anything. Everything is done.
And if you're a Maven user, sorry, Cédric,
I'm leaving.
there are equivalents to all of these commands. So to run native tests, you can do Maven test -p native. To run natively as well, I think there's something. To build a Docker image, it's Maven package -p Docker native, and builds native Docker images. So there's parallels in Maven, in our Maven plugin documentation that work the same way. Just it's not as good.
Yeah, you have to say it. I know, but so while you were talking, I actually launched a different command and noticed that now we have this native optimized run thing. So this is something that is optional that you can use with Micronaut, but it comes with, you have to understand what you're doing when you're doing that. So I'm going to come back to this build file while it's building and show you this section, which is called AOT. So this is the moment when we talk about the AOT module, which is there. Again, it's optional, you don't have to use it. But then what it does is actually something interesting. So it actually adds some optimizations that cannot be done just by the Java compiler. So what Graeme mentioned is that Micronaut tries to do as much as possible at compile time, but we're limited to what the compiler can do. And sometimes there are some optimizations that we can do, but are not possible to implement just with the Java compiler. So one example that I like is this convert YAML to Java. So Graeme showed you the properties configuration format, but you can also use YAML if you want to. And in this case, if you use AOT, then it would convert your configuration files directly to Java before shipping that into your application. So it means that at runtime, you don't need YAML anymore. You just have the configuration file as a Java.
You don't need a YAML parser.
Yeah, you don't.
So that means we don't need to load the bytecode for the YAML parser or the library because the configuration file is already in just raw Java, right?
Yeah. So I'm going to come to it. So another example is this replace logback XML thing. So logback, which is going to initialize, is going to take a few tenths of milliseconds to parse XML file and initialize the XML framework. And actually, what you've seen before is that it included this. So I think something else is actually bringing this Java XML thing. But ideally, we should be able to eliminate all the XML parsing from the binary in the end.
Yes, we should be able to do that.
And it starts a bit faster, 6 milliseconds and not with 5 milliseconds startup time.
Saved a few milliseconds off the startup time.
So there are some optimizations. So why it's not optimized by default? The reason is that you have some optimizations there which are sensitive to the environment where you build. If you run this, actually you should do that on the deployment environment. Like typically, this would optimize things like what beans are available in a particular environment, like the prod environment. Like it would say, okay, these beans which are just for dev, I don't need them anymore, so let's drop them, etc., etc. So there are some optimizations, and if you actually, if you ship that and I don't know, build that from that laptop and try that to production, the behavior will not work. Like it's going to break because the expected environment is going to be different. So this is really something that you should do in the production environment.
Yeah.
Right.
So you have to imagine what Micronaut is built for. Like it's built for dynamic reconfiguration for different environments. Normally that happens at runtime, where you push to production and we read your environment and it reconfigures it. AOT pushes that dynamic reconfiguration to the build time. So that means you have to run the build in your production CI, right? Yeah. To prepare the application.
So when we were talking about developer productivity, so something that I like to mention really is that for Gradle I can do typically Gradle-T test, and it started, and now if let's try to move both windows. It's going to be small, but let's try. Come on. I have to do that. Let's try to have this. Okay, so, and I like Gradle, but not that much. So I have this test, and now I'm going to add a test there. My down button is broken, so sorry. Every time I try to press down, it takes some time. Test something, which is super interesting. I'll set true, false. If I hit save, then the build is started and it fails immediately, and then I can change the condition, run again, save, and do that, right? So it is super interesting to have this kind of feedback, live feedback, and again, this makes the whole application available during the runtime. So it's, as you said, extremely cheap to test some changes which imply, I don't know, connecting to a database or whatnot. And actually, we'll have examples of that later. So let's go back to the slides. Boring slides, but slides. So in terms of performance, yeah, from Micronaut 3 to 4, there were already some improvements, you know, for startup time. 12 milliseconds. Actually, you've seen that we can go back to 5 milliseconds if we want to, but that's only because I'm using Linux and Mac. Yeah, this is actually some, because yeah, you can trust us, but some people are actually doing some benchmarking in the white, and Matt Rabel is quite famous for that. So he runs this benchmark quite frequently. I don't know if he's going to do that anymore.
I have no idea. No,
yeah,
but change the position, but
exactly.
Yeah.
So you have this performance comparison, like the startup time for different frameworks, so Micronaut, Quarkus, Spring Boot, whatever, and we're fairly good, I think. Like,
yeah. Also, I would say like dev startup time, i.e., when you run Gradle test or Gradle run, is pretty important for developer productivity. If you're waiting around for your tests to start up or your applications to start up, that's not fun.
So that's startup time, but then we have the native performance time, so that's on M1. In this case, yeah, we see that there's actually something quite weird, and I think it's specific to Matt's test, because the AUT version is a bit slower. But I don't quite understand this. This should not happen. But still, Micronaut is still faster than the other frameworks. And in terms of memory, yeah, more or less all the frameworks are equal except Quarkus. There's a reason why Quarkus is a bit fast, is a bit consuming less memory, but it's yeah, optimizations that they do differently for native. So in our case, we try to have the behavior of the native applications be as close as what the GraalVM version does, which is not quite the case for Quarkus.
Yeah, I mean, there's different approaches to it. GraalVM supports what's called build time initialization, where you can initialize types at build time, and or runtime initialization, where you can initialize the types at runtime. I think the Quarkus folks invested quite heavily in build time initialization, which is why they can shave those extra little bit of memory off. But I don't think the trade-off is worth it, because it makes the behavior different between JIT and native, because they're fundamentally different. And we're trying to, we kind of sided with the, in terms of framework design, with the Spring guys who said, okay, everything should be runtime initialized to maintain consistency between the two. I think it makes it easier to rationalize about particularly error messages and so forth with native image.
So I think you mentioned the term JIT, so maybe we said that several times, that when we say JIT, it's really Java with a JVM, like it's a simplification. So yeah, so we mentioned that, so it's just a summary, but basically the collaboration on the GraalVM metadata is done just not by us, it's something which is also supported by the Spring team, so they invested a lot. And basically the idea is that, well, Spring needs some metadata, we need some metadata, let's share everything, right? Yeah, so Micronaut IoT, the only thing that I've mentioned there is what you can do in the build script, but there's much more actually that you can do. So you can even implement your own optimizations if you want to. And in particular, there's one that we are doing in Micronaut security with JSON web tokens and things like that. So in general, you have to call a server at startup just to get some credentials. I don't remember exactly. I'm not into into this JSON token thing. But basically, at startup, you have 1 second which is purely lost because you have to talk to a server just to get something that can be done at build time. So this is something that we do with Micronaut IoT. So you can shave that 1 second of your startup time. The summary, so you can use Grails native test or Maven. But you know, you have to remember all those magic flags with that build tool. Stop doing that. Yeah, native test, it's so much easier. Should admit the data repository. So you mentioned that, I think, but the minimum for Micronaut 4 is 17. We had the discussion of whether we wanted to raise that bar to 21 for the next release, but I don't think we're going to do that.
Not yet, no.
And we have support for virtual threads, and yeah, it works also with the native images. So in terms of changes in Micronaut 4 which happened, it was actually started in 3, but really the effort was to make the whole framework more modular and have as much optional dependencies as possible. So typically before, the default was to use snake YAML, which means that you have this configuration file, which is probably a bit easier to read for humans, but then involves more startup time, more potential attack vectors, because, I don't know, a parser is always something that you can hack. Same for Jackson, serialization, so you're going to have a demo with Jackson a bit later, etc., etc. Caffeine, which was used for caching, and that was completely removed. I think we don't.
No, it was moved to module.
Okay.
It's still there. Everything we moved to modules is a Jackson module. There's a Snake YAML support is still there. You can still add the YAML support if you want. But it's really about making the defaults as lean as possible and then letting people add the features they want, right? An important change was the compiler and runtime split. So we used to have ASM. We used to have the compiler and the runtime in the kind of same jar, which didn't make much sense because you don't need those classes at runtime. So we use ASM in the compiler for certain tasks. And if some other runtime library depended on ASM, there could be a conflict, so we repackaged it. Now that all of that is we have in a separate compiler module, the runtime is smaller, 2 megabytes smaller. And we also made core just generally smaller, so splitting out things like retry support, not everybody wants retry, splitting out service discovery, so it's an optional module, validation, some people don't want validation for whatever reason. Their app is simple enough, or they want to do their own manual validation, you know. Yeah. So just making it more modular.
So I think for the validation from 3 to 4, there was a breaking change in terms of coordinates, but it's just
well, there were a couple of breaking changes. One is in Micronaut 3, we're using JavaX validation. One thing that I think we maybe didn't mention, or maybe it's in the next section. And in Micronaut 4, it's Jakarta namespaces everywhere for the validation modules.
I think we'll have to go very fast on this one.
Yeah. Yeah, we're going to have to move very quickly. I'll go very quickly on this.
Let me switch.
So one of the things so let's go over the core updates. And maybe I'll have to brush through some of the stuff. The dependency injection improvements we added, we'll talk about, and then generics and validation, the expression language, how that's used in BMappers, introspections, and a little bit about KSP. So I'll do a quick demo of dependency injections and enhancements that we have. So one of the things that you can do with Micronaut is define like configuration properties. So for example, I can create here a Java record probably that is, I don't know, let's just call it person configuration, doesn't really matter. And you can annotate it with @configuration properties, right? Add like string name, in age, whatever. So there's my person configuration. And this becomes by annotating it with configuration properties, what this means is that I can use configuration in my YAML file here to bind the values of this object, and I can also dependency inject it into another component. So, for example, if I had another class here, let's call it person service, it could, using my preferred technique, which is use constructor injection, we can dependency inject that into another component. So how do you make a component a candidate for dependency injection? And the way you do that is to add a scope. And the most common scope is singleton. So singleton means that there's only one instance in your whole application, right? So by adding a scope here to this class, I'm turning it into a component or a bean in my application, and I'm making a candidate for dependency injection. So now I can define a constructor, and the framework will inject the component if it's available. So what you can do is here I have things like whatever, and then we can inject the person service like that, and maybe in person service we can add just a getter, just so that we can get hold of the configuration, like that. And we can come in here and we can say person service get configuration, get hold of the configuration object. Oops. And we can add an insertion here. So it equals Fred config name, something like that. So this should work in theory, and it does, right? So what happens here is when the application starts up, it binds these values from the person namespace from my configuration, and actually IDEs are typically clever enough to already work out like code completion automatically, and that's how you do like configuration properties or injecting configuration into another component. And I can of course take this person service, and if I created another class here, which is my controller, you know, like you were demonstrating controllers before, I could add a controller which exposes web endpoints and inject my person service into it. And that's basically how you wire together components in Micronaut using dependency injection, right? Now, one thing that was common with Micronaut is Micronaut has to be able to adapt to different like configurations, reconfigure itself, or your application, for example, in the cloud-native world, depending how you configure your app, you maybe want to change the configuration or make it conditional. And one thing that you can do is use what are called bean requirements. And what you could say, for example, is that this requires that the person enable property is equal to true, right? So, and you can give it a default value, for example. Maybe it's true by default, right? And if I run my test now, if I run it, it's gonna pass, right? So it's still passing. But if I came in here and I said person enabled equals false, and I run my test again, now it fails, right? You can see that the error message has gotten a lot more useful, and this is one of the improvements that we added in Micronaut 4, is that previously you would get a no such bean exception, and you would have to go to the beans endpoint or debug your application to find out why the component was disabled. But now you can see it says there's no being of type person configuration is disabled because the property person enabled with value fast does not equal the required value true. So you get a kind of deep diagnosis into the path taken to creating the object, right? So it tried to new up person, it tried to new up person configuration, but it couldn't because person configuration doesn't exist. And why is that? Because it's disabled by configuration. So that's quality of life improvements in terms of error messages that we're trying to add and make it easy to understand, your configuration that you're defining in your application and why it's not working and so on and so forth. And it's gotten really smart in terms of, because we have another concept called each property, where you can have multiple configurations, where you can say each property people, and in here, instead of person, you say people, Fred, people, and you can have multiple people, right? And then this essentially becomes the qualifier for the component, right? So in here, for example, you can, instead of just injecting person configuration, you can say, I want to inject a configuration named Fred, right? And that will work equally well in if you need like multiple configurations, like if I have multiple people in my system or multiple things or whatever. But that led to also the case where if you get the configuration wrong, for example, if this was Bob, and I ran and I misconfigured my application, you can see now the error message is also improved, where we're saying there's no person configuration exists for the qualifier Fred. Person configuration is disabled because a configuration requires entries under the prefix people.fred. So we're giving you deep diagnostics into what is going on when you misconfigure your application, which I think is an important improvement. And one of the most important improvements, apart from also map injection. So now you can inject a map of beans. So in this case, if I had multiple people here, defined Fred, I had Fred, and here now I've got two beans, right? What you could do is inject a map of them where the key is the qualifier for each one, and configure your application whatever way you want. We've also worked a lot on optimizing performance and introduced Micronaut validation by default. Sorry, I just need some water. Micronaut validation, we moved to the declarative validation namespace, which is a big step. And also, Micronaut validation is the reflection-free replacement for Hibernate validator. You can still use Hibernate validator if you want, but we think Micronaut validation is smaller, thinner, and lighter. Well, I'm going to skip this demo and just go further on to Micronaut serialization. One of the things we added with the latest version of Micronaut validation is validation on generic type arguments. So now you can add, if you have a list of string, you can say list not blank string, and it will validate the components of the string or the map or whatever subcomponents that you have, which is very useful. The validation module is also optional, so you can remove it completely if you want. The way you add it is just adding a couple of dependencies. You need an annotation processor and a module, and it's pretty easy to use. The expression language is a big deal. Maybe we can make this demo a lot quicker by me just copying and pasting this, because there's one thing that is really cool about the expression language. So I'm going to create a new class here, which is the example job, right? So, and let's add some imports. Hopefully my code in my slides compiles. So Micronaut for a long time has supported scheduled jobs where you can just say add scheduled on a method and set a fixed rate duration. So it could be 1 second or 1 minute or whatever. In Micronaut 4, we added an expression language where you can use hash and then curly brackets to supply conditions, and it works universally across like the whole framework. But we've added specific extension points where you can use it. And Micronaut's expression language, I don't know if you ever tried Spell and Spring or anything, it's very similar. The main difference is that there's no expression parser at runtime. All of the expression parsing happens in the compiler, and all expressions are completely reflection-free and Graal compatible. So, and that's also a huge, huge, huge security benefit, because there's no way one of your developers can, crazily instantiate the Spring expression parser at runtime and take user input and do crazy things. It's much more secure, right? The actual parsing of expressions can never happen from user input, and the actual parser doesn't even exist at runtime, the compiler of the expressions. It also means that it's very type safe. So in this example, I can run the application, right? And look, we can do the whole go to terminal, and we can do the whole Gradle W make
Dash T.
Yeah, dash T thing to do the continuous build mode, right? And if I go in here and I made a typo in my expression, you can see I get a compilation error. And this is one of the real benefits of Micronaut over other frameworks, in that we can fail compilation when you incorrectly use the framework at any point and provide useful error messages. And you can see that across the framework, like with the expression language, or with Micronaut Data, where it validates your repositories or whatever it may be. Okay, so we demoed expression language. One other nice thing about expression language is it's already supported in VS Code. So you can see I can access all the methods of this class, and you get code completion, and it's already supported in IntelliJ. So it's already, the IDEs have already added support from this, and that's the great thing about Micronaut. It's reached a point of adoption and interest in the community where IDE vendors like the IntelliJ guys and we have great VS Code support in IntelliJ, and features get added and support gets added for it. And one nice usage of expressions is the BMapper stuff. So we added support for, you can continue to use mapstruct if you want, but we also added a simple API if you have DTOs or you want to map one type to another. You can very easily do that using the BMappers, which lets you on an interface declare a mapping from one type to another, and the logic gets implemented for you automatically, right? So you don't have to write the code. The framework writes the code for you to map one type to another. Which brings on to bean introspections. So I won't go a lot into this. We have a bean introspection module. Remember, we talked about how Micronaut tries to be reflection-free. And one of the things that you need to be able to do is read and write objects from a database, or read and write objects from JSON or in different formats. So we provide a way where you can do that using in a reflection-free manner. And it forms the basis for, and we added some nice features to it, for example. So this is how the API looks like if you used it programmatically. You can get an inspection, you can instantiate an object, you can set its properties. It looks a bit like a reflection, but underneath the surface, it's not using reflection. And in Micronaut 4, we added support for builders. And the whole of Micronaut serialization is based on this. So Micronaut serialization is a replacement for Jackson. It's reflection-free. It's much smaller. It's decoupled from the source code annotation DSL, so we support Jackson annotations. Pretty much all of the Jackson annotations are supported, but we also support JSON-B and BSON annotations. And we support running it on top of different encoders and decoders or parsers. So you can use the Jackson parser or the Oracle parser or BSON, and it's fully native image compatible. I'll probably skip this demo because we will probably run out of time. Otherwise, are we going to have a break? Probably we should.
We should, yeah. Do you want a break?
Yeah, we should have a break. And yeah, just a summary, we added support for KSP, which is a new, if you use a Kotlin user, it's a compiler plugin, only supported in Gradle.
Of course.
Yeah. And with that, that brings us to the beginning of part 3. So we'll have a short break, and then you will take over and do a big part of the demo.
Welcome back. So in this part, we're going to discuss one of my favorite features of Micronaut Framework, which is Micronaut Data. So maybe some of you are already familiar with Spring Data. Yeah? Okay, so you have the author Spring Data here. One of, yeah. So Micronaut has something similar called Micronaut Data, except that everything is done at compile time instead of runtime, etc., etc. So we're going to see the benefits of using that. And it comes with a close friend, I would say, which is called Test Resources. It's not just for Micronaut Data. We'll see about that a bit later. And in the process, we're going to talk about something called the Micronaut Control Panel. So yeah, the existing data solutions that we have today, like Spring Data, Gorm, or whatever, they have this problem somehow that everything is done at runtime, right? So you have these queries that you can write with an interface, whatever, and you can write whatever you want in the interface. The error that you're going to have is going to be at runtime at some point. There's no compile time checks, etc., etc., etc. The other problem is that in order to be able to do that, they have to build some introspections again, like to parse the method names and build some query at runtime. So it takes some time, it takes some reflection, and it requires runtime proxies again. So the goal of Micronaut Data is really to simplify all this, to make that as fast as possible and as compiled, time checked as possible. So so that we can use that in native images with zero overhead or whatnot. So I think I'm going to go straight to the demo for now. And it's going to be easier, and then we can demonstrate something. So the only thing I've done before when you were leaving for the break is that I have created one application using the command line, using mn create app. So I'm calling that application data demo, and the only thing I've done is adding 2 features, data JDBC. So it's Micronaut Data JDBC, so we have different backends for Micronaut Data, so JDBC, JPA, Hibernate, others, I don't remember which ones. And then you select database. In this case, I'm going to use Postgres, which is quite cool, just because it's super fast to start, so for demos, it's nice. And once you do that, you have a project created, which just looks like this. So in the build script, the dependencies that we would have is this Micronaut Data processor, and then we would have a runtime dependency on Postgres and the Hikari connection pool. So nothing really fancy, and now we have to write an application. So I'm going to do exactly what I started to do with the other project, and do that, start from this entry point. Create an application, start it, and we already see things happening there. So it took almost 2 seconds and a half. Let's modify that to use Gradle instead. What did you do, IntelliJ? Where's the window? I don't know. So I don't know. Sometimes I have this bug with IntelliJ. It decides that it's not going to use Gradle to start up. So that's not a problem. again, we can go to the Gradle window and do tasks application run. And I'm going to update that to use the -t. If there are some people working for JetBrains in the room, feature request, make this a default. Okay, so I have an application which started, which does absolutely nothing, right? But still, something happened. Like here we have a Postgres container which was started. Like this is actually a Postgres Docker container which started. So it means that there's a database, and actually it's interesting because I don't have Postgres installed on my machine, and I want to work with an application which is going to use Postgres as a database. Usually what people do is that they would create an application, do whatever they need in the data layer, and then for test they would use H2 because well, there's no database that they can use locally or in production, whatnot. And while it could work, the problem is that you're not using the features of your database, so you could have things which pass in a test and would break in the actual application. So the goal here is actually to use the same database for both the application and the test, right? So -t up, we go. Every time I'm going to start this, I'm going to pay 2 seconds of startup time, which is not great, but now let's start our application, and we're going to do something really interesting, like create an application which is going to deal with quotes. So quote is what is first an ID, then let's say an author, then a quote, and because we live in a world which is broken as possible, we're going to use something which says, is it a fake or not?
You might need to change that to a record.
When I say record, yeah, thanks. So to make that possible to store in the database, I'm using mapped entity. Oh, I should probably move to full screen. A mapped entity, and then, well, that's all I need. And I'm going to add some annotations like generated value and ID. And now I have this entity which is going to be mapped to the database. But I have to store it. So the way you do that with Micronaut Data is with this concept of repository. So I'm going to create a repository for this quote. And it's going to be a quote repository. And I'm going to annotate it with @JDBC repository, and then we specify the direct, which is going to be Postgres in this case. So you see all the different databases that we support, but in this case we're going to use Postgres, and then we can extend a basic repository implementation, which is CRUD repository, create whatever. And it takes 2 parameters. The first one is the entity type, and the second one is the type of the ID of the entity. So in this case, we have quotes, and then the ID is of type long. All right? So if we go to this base interface, we can see all the methods which are already implemented for us, which is nice. And if I'm going to do that with the test. It's going to be more interesting. I can go to this test, and similarly, just do that and update it to use -t, continuous. Okay, so now what I want to do, I should restart the test. Of course it passed. So now it's starting, and it should be listening. Okay. I'm trying to find the right split between the 2 windows. So let's inject our repository there. Again, I can do @inject, and then do private quote repository, and then in my test, I'm going to replace that with something useful. So I can create a quote, since it's a record, the first thing I'm going to pass, so the ID is going to be null because I don't specify the ID. It's going to be the database doing that. And then I have to pass the author. So let's say Graeme. I love Micronaut, and it's not fake. And I can save that. So do quote repository. Quote repository.save. So the error that you get there is because IntelliJ is compiling in the background. So there was this error, the typo that I made. Second save. Donc saved quote. And then I can do an assertion. Asset, let's do with null for now. Saved quote dot ID. So I expect this test to fail, right? I expect it to fail because once I saved my entity, the ID should not be null. It's just to make sure. So save, the test is running, and it failed. And I can do, instead it should be assert not null. Save and run. And the test should pass now. It did not. Is there a problem? What is the problem? What did I do wrong? Let's restart. I don't know. Maybe I made some mistake. Passed 2. Okay. I don't know. It passed. Probably IntelliJ doing something funky with the output. All right. So the test passed. So that's all we need to understand for now. So what did happen? So we have this application. We have this mapped entity, and what we can do in the repository implementation is basically declare some methods like save, update, whatever. And we can implement our own. So say I need a method to find all the quotes for a specific author. I can do something like that, like list quote, import, and then do list by author, string author, and that's all I need to do, right? I'm going to save that. And now if I do, let's switch back to run. If I compile my application, it's starting the container. The application is started, so it should run. So there was no error. But say now that I make a typo there and say list by foo. And save that. I wish I knew the shortcut to show that. So now we have this error which happens at compile time instead of runtime. So that's really the biggest difference between the previous solutions that we had and what we have in Micronaut Data. So everything that you have there is checked at compile time. So here I'm using IntelliJ Community Edition. If you have the Ultimate Edition, actually it would tell you directly without even having to go to the compilation step. It would say that this property doesn't exist typically. So that's so we can fix that. Find by list by author, and it also supports things like queries. So you can actually write some SQL query, like I don't know, select name from quote where ID equals -ID. That would be equivalent to another query, but just say optional string, and then I can give that. Thank you. I can give that whatever name I want. At the moment, I provide an ID, right? So if you have the Ultimate Edition of IntelliJ, you have completion there for the queries. But what is really nice again is that this is actually checked at compile time.
Yeah.
So if you make a mistake, if you make a typo, you don't have to wait until you have that specific query executed at runtime before you figure out that there's something wrong.
Also, if you have the latest VS Code Micronaut extensions, they also support completion of SQL and completion of and checking of the methods. If you prefer VS Code IntelliJ.
It is, this query in particular doesn't have anything specific, but this is specific to the dialect, yeah, that you would use. So let me actually run this project in IntelliJ Ultimate because that would be interesting to show while it's loading. Okay, so while it's loading, I can actually talk about the. Whoa, it's missing. Oh, it took a few seconds to refresh. Talk about what happened in the background. So I don't have any database. Again, Postgres is not installed on my machine. But still, I could run the test. I could check out the project, say it was on GitHub. I could check out the project, run the project. I don't have to know about any of the prerequisites of that project. I just run the test and it works. The way we do that is with Micronaut Test Resources. And if we open the build file, you would see that in the beginning of the build file, you have this project, this plugin called Micronaut Test Resource. And this is the plugin which is going to handle these test requirements for you. So we call that test resources because this is resources that you need for your test at the generic term of resource. Like a database is some kind of resource. But it is not specifically for databases. It could be for any kind of resource that you need. So Kafka container could be, I don't know, an email server, or it could be a local file if you want to. I mean, it's not specific either to test containers or test Docker containers. So it should be loaded now into this one. So IntelliJ version Pro. So let's go to the quote and then open the other one, which was quote repository. And there you go. Okay, so currently actually IntelliJ doesn't know anything about the database schema. So how can we make that aware of what is in the database? So that's something which is interesting, and again, it's going to be easy to support just by adding some configuration into my build.gradle file. So I'm going to add one module there to the test resource configuration. So I'm do additional modules non-modules.control panel. And now I can go back to my application, start it. Come on, don't ask again. It's silly. And if we go up, there's going to be one link. If I can find it. There you go. I can click there, and we have this thing called the control panel open. So the control panel basically gives you the list of all the test resources which are handled by this application. So in this case, we have a Docker container, and we have the ID, container ID if you want to play with that. But usually what is more interesting is that you can go to this Postgres test resource, and it tells you everything which was resolved by the test resource resolver. So in this case, we have 3 properties which were actually resolved by this test resource process. So one of them is the password, the other one is the URL, and the last one is the username. Why is it interesting to see that in action? So we have 3 properties, but if I go back to my application there, and go to my application.properties file, what you can see is that these are properties which are actually missing from my configuration. So this is where the magic happens with test resources and Micronaut Data. So what we say in the configuration is basically I need a Postgres database, but we don't say how to connect to it. We don't say the credentials to connect to it. What we say is that actually we have this test resource plugin, and it should be able to feed that to the application if it needs it. And this is exactly what is happening. The fact that the property is missing is going to trigger the resolution of that, and as a side effect, a database is going to be started. So now that I have this, I can actually copy this into IntelliJ and go into the database browser and add a new data source like Postgres and configure it. And I can copy the username, password, and now I have this schema available with just the quote, and for now there's nothing stored in that, and we're going to see how we can do that. But now what is nice is that if I go there, I should be able to do something like from quote. So there was actually a typo in my query. Why is it complaining about name? It's author, see? So that's interesting to have that. So now you have the completion there. So always interesting. So that's cool, but we did not store anything into a database, so it would be nice to do something with it. And for that, we're going to create a REST API. So again, doing the dance, edit this configuration at -t. Oh, it's already there. Oh, that's because I'm on the wrong window. No, I closed the wrong one. Sorry about that. Let's reopen, and you go away. Data demo. So let's create something so that we can store data in that database. And for the run, already I did it, so that's good. Let's start it. So what I'm going to do is create a controller. So let's call the quote controller. It started, and just add controller / quote. And this controller is going to need my repository. In theory, well, you would not use the repository directly in the controller, right? You would use a service which actually uses the repository. But for the demo, this is going to be good enough. Private final. So it's injected now. By the way, IntelliJ shows you these nice things. So the injection point, again, that's something which is only in the
in
Ultimate edition, yeah.
One thing that is nice as well is that you got continuous mode running, and then it only restarts the app, but it doesn't restart the container each time. Each change just restarts the app.
Yes. Except when I stop the application and restart.
When you stop.
But we're going to see how we can work around that later. So the application is started, and you will notice that currently I'm in create drop, so that's important for the next features. So let's add something to this and say we're going to create a get method which lists all the quotes and list all, and then we return quote repository dot list all. Find all, sorry, find all. So I'm doing something that you shouldn't do, like returning directly the database object, but we're going to see how we can work around that later. Okay, so once I've done that, the application is restarted, and then it means that I can query it with, say, HTTP. So HTTP get, and it's port 8080 / quote, and it should return an empty list. There you go.
Yeah, that's cool.
So that's JSON, right? So it's cool, but how do you store? Well, to store, we have post. So let's do some post method. And then we're going to save something. And we need an author. We need a quote. And we need to tell if it's fake or not. So let's do with /add. Again, that's so that you can see that more precisely. So I'm going to do quote repository dot save new quote and then null. The next one is the author, the quote, and fake. I can save, go back there, and now I should be able to do a post. Actually, I'm going to do HTTP post, like because I'm lazy. Let's go pick this one, and just to replace, because JSON is hard to write, right? So we need to post on /quote /add, and then the data. So the data is the author, and this time you're going to say Gavin King. The quote is going to be I love Micronaut Data, and a fake is true, unfortunately. Internal server error. So what does it say? No server. Oh, okay. So that's interesting. So that's the improved error message that you were mentioning before. So Micronaut is telling me something. So the quote was actually saved, but because I'm returning the database object, which is quote, it doesn't have any introspection. And it's not allowed to be serialized by default. Like in order to be serialized, you have to annotate it with @introspected.
Assertable, I think.
Assertable, sorry, yeah, assertable, so that it's converted to JSON. But it's not great to do that directly on the database entity. So what I'm going to do instead is to create a DTO object. So let's say quote DTO super name. I'm going to use exactly the same properties for now. String quote and then fake. And this one I'm going to do the servable. So I have two options now. Either I use the mappers that you showed to actually return here a quote DTO directly, which is an option. The other option that is available in Micronaut Data is that in my repository, and I'm just going to show that there, in my repository I can actually say create a new method called list quote DTO. No, in this case I was saving, so it's a save. Save my, I don't know.
I'll go insert or something.
Yeah, thank you. Yeah, we have different notations. So you can use save, insert, and persist, right?
Add.
That's where in native speaker it's much easier to find synonyms. So insert quote, and then we have name. Sorry, let's do author. String name. No, it wouldn't be, no. That's not what I want to do, right? Probably want to use this this entity there.
Yeah, you can just put entity. Easier.
Probably can do that. There, and the controller, I'm going to use insert quote and then quote DTO. Did I put the servable? Yes. So let's save again. Too many windows open. And let's switch back there. What does it say? It's maybe not restarted yet. Did it? Was it? That's not the one. Unsupported for a return type. Oh, interesting. it's not supported for return types.
I think DTOs are supported for insert return.
Right. So I made a mistake. Sorry about that. So it would be for list, like if I do a list. Typically, yeah.
No, I don't think in general that we support. You probably have to.
Oh, you do. We do.
Do we?
I checked it. Yeah.
Oh,
yeah.
we did.
Yeah.
Okay.
The only thing I've not tested is, of course, the insert. So anyway, so not very important in this case. I can just work around just doing that. So don't do that at home again, but I can just do that for the demo. Save. That's all. And do code, because otherwise we won't make progress. Again, started. And now my data is inserted, and if I do a list, it's there. Okay, so now every time I make a change, so say I add something to my controller, like get /fake, which returns a boolean, is fake, and then say I don't know, long quote ID, and I have to implement that method. If I do that and I do refresh, then yeah, the application lost all the data that I've used, and that's because we have used this property, which is create drop. So every time you're going to save something, it's going to erase the database and then spawn up with a new schema. In practice, when you develop the application, you would probably not do that, but probably have the none here and use something like flyware or whatever to manage the database schema in this case. So here I'm just going to change that to create, just for the demos. So what it means is that the initial schema is going to be the same, and then it's going to persist all my changes across the different sessions that I'm doing. So I can do that. I didn't need to restart. I don't know why I've done that. Let's go to this. So the database is empty. I'm adding the quote. Now if I go back to the controller and change to return true, and I list again, oops, sorry, on the list, I'm going to have two entities because this time it was persisted, right? So this is already quite a good feedback and feedback pad time, because the database was only spawned once. So for Postgres it's quite fast already, because it takes maybe 1 second, 2 seconds to start the container, but it could take much more time. And in this case we have other options that you can use. So I'm going to stop the application and then switch to the command line. So here I'm going to call a Gradle task called start test resource service, which is way too long, so I'm just going to use start TRS. And what it tells you now is that the test resource service is started in standalone mode, and you can stop it later. So I'm going to open this control panel where the URL is there. So you can see that now there's no container started. So the application hasn't requested any property yet, because we just started a service which is going to serve some database containers. If I start the application now, the first time it's going to start the container. So when I refresh, now I have this test resource alive, and we have the properties resolved. But if I stop now my application and restart, then compared to the previous case, the service is still alive. It's still there. So it's going to reuse the same database. So it survives the fact that you stop or not the different builds. So you don't have to use this continuous mode. Like, you can have these containers survive across different builds. So build sessions, in fact. So that's a really, really neat thing that you can do with this. Yeah, so once you have finished, you can do stop test resource service. and then it means that the database is shut down, and then you cannot interact with it anymore. So control panel gone, right? So something interesting now, and it's probably easier to see with this this interface like directly on the console. So now if I do Grail test, I'm going to, Grail test. It's going to run my test. So it spawns the database, runs the test, and then we're done. But now I'm going to do this native test that we talked about before. So now my application is going to run this test with native, but native still needs a database. So we can actually do that using this test resource service. So what I didn't say up to now is that we really have two different separate processes. One is your running application, and the other one is this test resource service. And they run separately, but they communicate with each other. So it means that when we're going to build this native application, actually the test resource service is still a Java application, pure Java application. So despite the fact that it uses test containers, despite the fact that it has Postgres, database drivers, etc., so things which are sometimes quite hard to make it work directly with a native image, the fact that we separate that means that the native application is going to be isolated from whatever you use for tests. So we're only going to test your class-path application and nothing else. So everything that you use for your assertions or whatever is going to be separated, at least for the test resources part. So hopefully,
I think it has some benefits to JIT as well, because when you put test containers on the class path, it introduces extra dependencies that are not in your production class path, which introduces differences between your production class path and your test class path. And having those as similar as possible, I think is better.
Yeah, and so something that is happening there is that we are in a single build session. So I run native test, and actually to run native test, we have to run the JVM version of the test before. So the JVM version, so the test, the typical test task is going to run, use the container, and then the native test is going to reuse the same container. So we don't have two different databases. We're going to save the time of spawning two different containers. So native test is finished, and then it reused that container, right?
One thing to probably point out as well is Micronaut test, when you add Micronaut test to a JUnit 5 test, each test method will run in a transaction that's rolled back when that method finishes, so that your state is not persisted across.
So in this where's the test? Here there's a transaction going on, like which is rollback. So actually there's a parameter that you can pass there, which is rollback false if you really don't want that behavior.
If you don't want that behavior, you can disable it. And you can also disable completely transactionality if you prefer, for the data to persist across your tests.
In general, I would say that it's rather better idea to have transactions and roll back everything, especially if you have concurrent tests. If they talk to the same database, you can have surprises. So
if you don't roll back, then you would need to add teardown methods that clean up the data at the end.
Okay, so that's the basic demo for Micronaut Data. Basically what we've seen is that this repository thing is automatically implemented for you. We have this query thing which is quite nice and supported in the IDs. And the underlying technology there which is used is test containers that we integrate in such a way that you don't have to manage manually the test containers annotations in the test or whatnot. You don't have to manage the lifecycle of all the containers. It's all done for you transparently. So this is just a cheat sheet for when you read that later. So all the comments that I've used, and especially think about this start and stop for test resource service if you want to improve your local developer productivity, this is the thing that you want to use, like reuse the containers for your development session, basically. There were some improvements in Micronaut Data and Micronaut 4. So in particular, there was a module added for Hibernate Reactive. So again, just with the same kind of declarative approach. So
yeah, I particularly like the one on decoupling it from validation. So previously, validation was always enabled in the repositories. So if you called save, it would validate the entity. So now it's not validated by default, but you would think that that's a bad thing. But because we added support for annotations on generic type arguments, you can say extends CRUD repository at valid person as the type argument and enable validation everywhere if you want to opt into it. So it's now not like if you're focused on performance, you don't want validation in a way. So I think that's a nice announcement.
I think that maybe I'm going to and I'm saying something wrong, but something which is also interesting with Micronaut is that you can have I don't have the Jakarta, I do actually. So you see that we have two different annotations from non-null, and I think that you can use either. And that's one of the benefits of using everything at compile time is that we can map different annotations we have the same semantics to a single one.
Yeah.
So it doesn't matter if you actually fail and say, oh, I used the wrong one. Like it's going to work in any case.
Yeah, you know how many nullable annotations there are out there in the Java world? There's like dozens of them. We have this one class that maps them all to one thing. So regardless of where you import it from, it just always works.
Yeah. So ideally you should be consistent, but consistency in developers is a different story. Okay, so that was the. Do we have time for that? Yeah.
Yes, we have time.
Okay, we do. So test resources. So I've showed that for just Micronaut Data, but you can do that with different kind of resources. And so let's go and open a different kind of demo, which is I think quite nice. Also, see what you can do with native and whatnot. So we're going to use MQTT. So the use case is basically imagine that you have an application on the phone where you're going to send messages to the heating system to set the temperature, right? So you have a client application, which is the phone, and then you have a server application, which is going to drive the heating system. So they talk to each other using this MQTT message bus. So I actually have two different projects there. One is the app, like the server, which is going to drive the heating system, and the other one is going to be a CLI application, which is going to emulate what you would do with the phone, right? So there are two different applications in two different repositories. You imagine that they are maintained by two different teams, but still we can make that testing easier with test resources. So let's open the app first. And while it's loading, I'm going to load the second one, which is the CLI. There you go. So let's close the data one. We don't need that anymore. And let's see what the application looks like. So source main Java. Again, there's nothing fancy in the main entry point. What is interesting is this. So with Micronaut, you would annotate, so the server needs to listen to these MQTT topics. So it subscribes using this annotation, and then using just a data array, you can just receive whatever is on a specific topic. So it does nothing fancy, just reads that data, and it's a UTF-8 string and just logs it. So it's a super app, but just enough for the demo. So I can run that application. It's going, don't ask again. Why do you ask me to don't ask again every time? It's just crazy. So you've seen that once I have started this application, it actually started a HiveMQ message bus, right? And container started, and my application is listening. So now I'm going to go to the CLI app, and the CLI app is nothing fancy either. It's just a Micronaut Pico CLI application, so it just have a little more because it can pass. Don't ask again. Thank you. This one, yeah. So it has this CLI interface. So you have command line. You can pass parameters like -t for the temperature, the scale, Fahrenheit, Celsius, etc., etc. And if you do nothing, if you don't pass any parameter, it's going to set the default to 20.5, which is way too much if you want to save some energy. Should be, what, 18, said the president, something like that. So this is the CLI part, and then the producer part is called a publisher. And again, you have nothing to implement. Micronaut is going to do that for you. So you're just annotating the client with @publisher, and then it publishes to the same topic, and publishing to this living room temperature, right? So it's a CLI application, so I can run that, and hopefully, if I go back there, we should see something happening as soon as the application is compiled and sends the message. There's a mistake. Ooh, what's the problem? Server URI must. Oh, that's because I cannot run that from the IDE. I need to use Gradle run because I have configured an entry point. So let's do that. Yeah, it's again the fact that So if you are using IntelliJ Ultimate, just be aware of that. So IntelliJ Ultimate doesn't delegate to Gradle for the run application, and it causes some issues. So just don't do that, and instead use again the Gradle integration. So or Maven would be the same problem. Gradle run. Where you run? Run. There's no run. So let's build the application then. Not Java. Gradle assemble. We could do native run. Actually, it's going to be interesting. So let's skip this and do native run. So what I'm doing now is even more interesting. So instead of having just two Java applications talking to each other, one is my server, which is started in GraalVM mode, and then I'm compiling the CLI client as a native application. And they should talk to each other, except that I forget one parameter. You should have told me, which is the magic keyword when you want to use native. And test resources.
Yeah, I created an alias for that.
Native run. So you have to do -d test resource native true. So only for run. Topic published. Oh, that was fast. There we go. So you have this CLI application talking. So if you don't believe me, I can go to build native compile, and then set the temperature to 666. And let's go back, and there we go. So in this case, it works. The way it works is not the behavior by default. Like normally your projects are isolated. So if one uses a database, the other one is not going to use the same database, right? So that's not a behavior that you want by default. So it's an option that you have to configure. And the way you do that is just using this flag in the build script, which says shared server through to true. And if you do that, it means that you want the test resource service to be shared between different projects. And something which is something that you could try at home if you want to, but you can actually share the same service between Gradle and Maven. Like you could have one team which is a cool team using Gradle, the legacy team using Maven.
Yeah, imagine
And
if
you would still be able to test the application entirely just checking out the two projects.
yeah, I think it's quite common in like messaging applications. You might have one application, maybe it's your API that's like sending Kafka messages,
Yeah.
and then another headless message-driven microservice that's just listening for the Kafka consumer. So you want to start one, start the other, share the same instance of Kafka, and the same test container, essentially, for local development, and have them coordinate in between others. So you enable a shared server, and you can share a single container between two applications.
So we have 10 minutes left. Do you want to go with a spot?
Yeah.
All right.
Well, I don't know if I'll have time to demo, but we'll just go through some of the other stuff. So yeah, the test resources stuff as well. You can configure like your own containers. Like there's some kind
Yeah,
of
it's a declarative DSL where you can actually, if there's no support for like in this case like an email server, but a Docker image which provides that, you can actually declare
you can
something.
declare it in your application configuration, even if it's not supported out of the box. So if there's some known container that's publicly out there on Docker Hub or whatever, you can just pull it in and configure it and use it as a test resource. But there's like built-in ones for all the common, most popular databases and so forth. And the control panel thing was really useful. You demoed.
Yeah, because I've shown that actually in test results, but that's not specific to test results. The control panel is something that you can add to your own application and you can implement your own panels.
Yeah.
So for monitoring, this is quite interesting.
Yeah. There's lots of guides on Micronaut Data out there for different databases. As we said, we support lots of different databases and data access methodologies, techniques. We support JDBC, which is what we've been demoing, but we also support Hibernate JPA. So if you prefer, from my perspective, like JDBC is simpler, it's faster, more performant, easier to reason about because it's stateless. JPA is a bigger thing that makes more assumptions about session and synchronization and state. But it has its benefits. I think JPA has definitely probably a lot of benefits if you have a write-heavy application for batching writes in a session and doing them in bulk. If your application is read-heavy, I would probably prefer JDBC because it's faster and it's stateless. So and then we support things like MongoDB and various other document databases. So let's move on to the web and cloud stuff. So virtual threads, we added support for virtual threads in Micronaut 4, and it's really just a matter of like one line of code, one line of configuration. The default in Micronaut is netty, so it has an event loop and it runs workers on the same event loop. But you can offload from the event loop to another thread pool, and in this case, virtual threads. So you just configure it, and you can offload all your I/O to virtual threads. Note that virtual threads are great for I/O bound kind of operations, but where there's input and output, but they're not appropriate for CPU bound operations. Just keep that in mind. Not sure how much you looked into virtual threads, but basically if you're doing on the virtual thread, if you're making an HTTP client request to something else, or calling Oracle database or some database, that's a good use case for virtual threads because whilst that interaction is happening with Oracle database or with the HTTP client, the thread is unpinned from the physical thread, and another virtual thread can run on that same thread, right? But if you're doing a lot of CPU work on the virtual thread, basically occupying it, you're basically pinning the carrier thread, right? So it's not a solution for CPU bound work. but for a lot of blocking virtual. And we made the whole framework aware of Loom. So we added a new API for writing filters that is Loom friendly and removes reactive frames if it's like running in a virtual thread. So if you have your whole filter pipeline just using blocking and virtual threads, it will remove stack frames and make that simpler, because reactive stack frames are quite complex relatively. We added like incubator support for HTTP3. It's not production. Well, I mean, the HTTP3 support in Netty itself is still in incubator state, so it's not regarded as finished or complete. So we can't make it like. But if you want to try HTTP3 with Quick, HTTP3 is a fundamentally different protocol. It's based on UDP instead of TCP, and completely changes the way HTTP works into a kind of binary format. So it's a big change, but has a lot of benefits in terms of multiplexing and so forth. So, and we have some initial support for it for folks who want to play with that. I mentioned the context propagation, so we added support for context propagation, open telemetry, Micronaut observability, and just made the whole kind of distributed tracing, reactive transaction management better. So there's now an API that you can use from filters where you can pass in like the propagation context and store things in it, and then it'll propagate things automatically for you. It's a lot simpler, the API. We updated all the cloud modules. I think I've only got 5 minutes left, so we're going to skip this.
Yeah, unfortunately.
But yeah, Open API module is very cool. I'll just point out, check it out. It's one of the demonstrations of the power of Micronaut's build from compilation time approach. So it has various modules. One of them will generate Open API specs from Java sources, so kind of code first approach. But we also added the ability to generate Java sources from specs using Gradle or Maven. So if you're doing contract first development, so we now support both. You can even round trip them. You can generate from source and then generate a client from that generated.
And it supports generating both the client and server stubs.
Server stubs, yeah, as well. So yeah, it's pretty cool. So it has a Maven and a Gradle plugin. To generate a client, you point it to a spec, you point it to the package where you want to generate stuff, and it will generate, and you can dependency inject those components into your application and make HTTP calls, and it's pretty nice. And for stub generation on the server, the same thing. You can configure it, generate the stubs, you implement them, and you fulfill the contract as defined by the OpenAPI specification, which is pretty nice. I think we already did an introduction to Graal Cloud Native, but I'll just point it out again. It's a curated set of modules that are built at Oracle with a kind of subset of the open source modules from Micronaut that Oracle provides support for. But it's also like an opinionated set of generators for multi-cloud applications, and we have vast test suites that test that you can build cloud portable GraalVM native applications and run them on AWS, Oracle Cloud, Azure, GCP, etc. Actually, I should update that because I think this week we released the latest version. It came out a couple of days ago, and that shipped with the final Azure and GCP support. So it's now there. So we support 4 different clouds. The idea is that we kind of captured like cloud services into like concepts like object storage, logging, and metrics. So you just say you want one of these things, and it integrates them with the cloud that you're running on. So where to learn more? We have great documentation, docs.micronaut.io. I think our user guide is like 300 pages long, and we have different modules. But we also have, if 300 pages is too much to digest, we have short guided tutorials at guides.micronaut.io, which with like kind of task-focused kind of short guides with each of them with source code. And we also have virtual labs and cloud native guides on the GCN website and the GraalVM docs as well. And also you can follow Micronaut on social, on Twitter or X or whatever it's called, on Mastodon, and etc. So what's coming? We are releasing Micronaut 4.4 very soon. That will release support for OpenSearch. We already had support for Elasticsearch. We're adding an OpenSearch module. We're adding support for HTMX in the Micronaut Views module, and parameter expressions in Micronaut Data. And then we will add, then there'll be Micronaut 4.5, which will come with a rewritten HTTP 2 and HTTP 3 stack that's not using the adapter that native provides, but it's actually using the channels, and it'll be better and faster. We'll have JSON schema support and multi-tenancy by discriminating from Micronaut Data. So in summary, Micronaut is awesome. Everything is awesome. It provides high productivity and performance, and Micronaut 4 is improves on that even more. The GraalVM integration is great and getting better all the time. And I think with that, we can say thank you and leave 1 minute for Q&A, if there is any time. What? Any questions?
Thank you for your presentation. It was great. Thank you. Everything is awesome.
Everything is awesome. Yeah.
So, is it are Micronaut application destined to be run on GVM or finally as a native image? What is the ultimate task target?
It's up to you. I would say today, as of today, most of our users are deploying to JIT and Java. But we do have a large native image user base as well. So, but it depends on your use case and what you want, right? If you native and JIT have trade-offs, right? And like one of them is portability of the application across different.
If you have a big monolith, I think
native
is probably not a good idea.
You want to start off with JIT and then look native in the future. But if you're starting fresh, then absolutely, like we provide the tools where you can go native from day one. Right.
Is there a way to functional test your application with the same limits it would have on your pod on Kubernetes to set the? Sorry, it's probably a Java question more than a Micronaut question, but to set the CPU limits, memory limits on your functional test. Is there an easy way?
So you're talking about like running your tests in a container. It's actually a nice feature request. That'd be cool. Yeah. No, but it would be a good idea. I like it because we've often seen like because somebody deploys to a 1 CPU Docker container and then something goes wrong.
I think we have options to build in the container. But
it would be good to be able to run the test in the container.
But not run the test. Yeah,
it's a good idea. I like it. We should do it.
Okay, thank you very much.
Thank you.